But now we want to talk more about the reliability, right? We just did a lot of heavy network touches. We configured V4, we configured Fabric, BGP, but we never made any, we did not have any fail safe checks, right? We never looked at the diffs of the configuration changes. We never really run a dry run, something that is very important. This would be your typical Ansible stuff, right? Fire and forget, just push the configs to the nodes and let it be. Kind of the push and pray tactic. What we want to ensure with the systems like this, if you build all these abstractions, you don't only want to have the configuration push, you also want to make sure that it's reliable. You need to know what exactly has to happen before you start configuring your nodes. You want to have this reliability that we are quite proud of in the EDA system. And this is why we say that EDA brings highly reliable systems. Now, what exactly that means is that if you take the Kubernetes pattern again, they use reconciliation, which is a super nice idea. It means that you submit a resource like the Fabric, and the constant wheels will chug and spin and make sure that the Fabric will be eventually on the nodes configured. But the eventuality is not good for networking. You don't want your ACL policy be eventually deployed. You want it either to be deployed or not deployed at all. It needs to be binary. So that is why the reconciliation is great for workloads that are not critical. Like if you deploy a pod with your web server and you have 100 replicas, if 99 of them work, great, one will come up later or maybe never come up. You never know, to be honest. You just need to constantly check and see if the change will be there. But then with networks, we really need something more reliable. We need transactions. And the atomic transactions, the atomicity or ACID principle says that you need to either have a change on your target nodes or not have any change at all. This is why what we have in EDA, transactions. Transactions allow you first to couple a lot of changes together before you apply them, not just single object by single object. Have a group of objects and transact them in the same way. Now, the transaction will do quite some interesting things because it will not only check that the transaction can succeed, but in the case that transaction fails on any of the nodes that are targeted by your transaction, everything will be retracted back. You will never have a change that is propagated to one of the 50 nodes and the rest will be, in the dangling state. These will be a very cool thing to have out of the box, and this is what we offer in EDA as well. This transactionality and guarantee that your transaction either there or not there at all. With transactions, you also have this kind of multiple safe checks, right? You have schema-based input validations. So if I would put in the BGP ASM number some text, the system will not let me even try to commit this. This will be intercepted by the first steps, the schema validation, before you even start talking to the nodes. Then there is dependency validation. If you have to rely on a pool and the pool is not there, you will not be able to even start checking the transaction over. And there is, of course, the node validation. That means that if the node rejects something, maybe TCAM memory ran out and you want to configure 1 million of ACL rules, the node will reject it. This will fail the transaction, and everything will be wiped out immediately from the other nodes. We also persist the transactions in Git, which, as you may have guessed, will allow you to roll back any time from the system. If you happen to make a bad upgrade and something did not work, you can roll back to the previous state. Your nodes will unupgrade or downgrade, and you will be able to see this live. So I have another demo. Imagine that you want to create a node user, right? Something that you can log into the nodes with. So we manage node users in a different panel in EDA. So we switch to system administration. That is where you can create things like users, groups, this kind of stuff. So if you check, there is a node users application in this system panel. There is an admin user, the one that I used on the nodes, the admin Nokia SRL1 exclamation mark. But I will create a new one. I want to create a new user. I will say that my new user is called test user. I will create it in the namespace. And I will select this. So it needs to have a group bindings. The group bindings is just a way for us to make sure that this user belongs to a group with certain permissions. So here, actually, let me copy paste the YAML. It will be just easier than going through, given that we don't have enough time now. So I created this test user. As you can see, this test user uses the pseudo group. That means that it will have admin privileges on the node, and it has the username test and a password test, right? So now when I create this user, I will do, instead of committing it, I will add it to transaction. We never did that, and I never did it on purpose because I wanted to show you transactions here right now. When I added the group, a user to a transaction basket, it appears here in my transaction workspace. I can add more objects to it. Remember that I said that we can combine objects in a transaction basket, right? So that we can apply them all together. So now my user is in the basket. I will also do this. I will show the watch here. So we will set up a watch. Let me copy paste this command. So right now, there are no users besides admin on my system. That is why the output is empty. The admin user is not in the same path, so we don't see it there. But we will create a regular user called test. So now I'm every other second, I'm looking for a user in my leaf one. So I will go back to my transaction, and what I will do is I will just commit it, right? So I say commit now. I click commit, go back to my terminal. Yes. I wanted to show you the diff first. So if I committed my transaction, I can also look at the diff that this transaction resulted with. So I can commit a transaction and see what exactly this transaction resulted in. On the left-hand side, you will see this node configuration tab here, right? And if you select the node configuration, it says that the transaction only targeted spine 1. You see node configuration spine 1. That means that our user has been created on the spine 1 system only. And that is because in our transaction, we have this label selector that selects the spines only. And my diff show me the CLI configuration that I have, right? It says you are creating the user test, this green block, with password that has been hashed, of course, so you don't see the source of the password. And my role is sudo. This is the sudo group that we used in the configuration of the user. So this is something that you can look after you made the transaction and before as well. So we will now see what actually makes, how can you ensure that the configuration that we intend to make is exactly what you want to do. So now you see this test user is here. You can also edit this user and, for example, say, I want to change the password. I will add it here right now. What I will do, I will add the leaf, right? So I will role equals leaf, add to the list, add to transaction. I'm following the same steps. But now before I commit, I want to make sure that I will target my leaves. So what I can do is that I can run the dry run. The dry run is a mechanism in EDA that allows you to run the transactions syntactically without talking to the nodes. So you don't need to have a network connectivity to the nodes. You can use your virtual system, as I will do here as well. And with dry run, you will be able to run the transaction, run all the checks, and see what diffs will it yield, right? So if I click dry run, EDA will check that I used the right label selector, that I used all the right parameters for my node user. It's a relatively simple one. But now you see that dry runs succeed, and I can check the diffs of this dry run. Now remember, the dry run does not touch the nodes. We did not configure this user on the leaf. So in fact, if I go to my shell here and I use this command with watch on the leaf, there is no users. But we just ran the dry run of the transaction, and now the dry run shows us that we now configure leaf 1 and leaf 2. We also configured the spines in the previous step. This transaction is there. Now we added a new node selector by adding leaves, and EDA figured out that 2 nodes have this label on them, and it will configure the user test on these two leaves. You can browse your diff and say, yeah, that looks correct. I know that I wanted to have on my leaves, leaf 1 and leaf 2. Sounds fantastic. I will close the diff view, and now I can commit, right? So now I'm committing this stuff. And you see it's already there. I was not even able to switch in time. The leaf now has this test user. Because we run the dry run, we verify that the test user will be on node 1 and node 2. Then once we committed, it became live on the leaves as well. Okay, so now I wanted to show something else. What happens? Remember this fairy tale that I told you that if something does not work on one of the nodes, nothing will be enacted, right? If something is not working, it needs to be not applied to the nodes. We don't want to have these dangling configurations. I will do another test here. So let's see that, let's imagine that I want to make a new user, like test 2, for example, on all of my spines and leaves. I add this to a transaction. But what I will do now, I will go to my leaf, let's say leaf 2, log into that one. And what I will do is that I will enter the candidate mode, but I will enter it in the exclusive mode. What exclusive mode means is that for anybody else besides me, there is no way they can make changes. It's locked. It's kind of netconf lock. So now when I want to configure something on this leaf, I will not succeed. There is no connection. There's no way I can open a candidate and do something. From EDA perspective, that means that it cannot talk to the node. It cannot enact the configuration on it. So if I now want to create a new user, I will do the dry run, right? My dry run will succeed because the dry run does not talk to the nodes. It's all syntactic. It's in the system. All the validations happen there. It assumes that the node runs a particular Linux version, does all the schema checks, does a lot of smart stuff, but it does not talk to the nodes. So now, if I try to have a look at the diffs, I will see that the user needs to be changed from user test to user test 2. That is what we did in our intent. We changed the name of the user. And it targets 3 nodes, leaf 2, leaf 1, and spine. Sounds what we need to do. But now if we hit commit, have a look at this. By clicking the commit, EDA will start trying to connect the nodes and enact this change, but it fails immediately, which means that it was not able to create a successful transaction. And if we go to the details of the transaction, you see here, I will make it bigger. It says, cannot start an exclusive configuration session on node leaf 2. That is why, because we locked it. But the whole transaction failed. It's not just leaf 2. It's spine 1 and leaf 1 as well. All of them have been retracted their intended configuration changes. And if I go to leaf 1, there is no user with test 2. It has the same previous test user. So this is the constant watch that refreshes. Otherwise, we would see the leaf 1 having user test 2, but it does not have it because the transaction failed and the changes never applied. You can imagine that if you deploy your configuration, you can always run a dry run. You can verify that it's syntactically correct based on the schema validation. But if you do not have this capability of talking to the node and see when it fails, retracting the whole transaction, it will be quite hard to achieve the reliability of your network changes. And maybe you wonder how it works. So what it does is we use commit confirm. When we create a configuration, we use GNMI with commit confirm capability. We enact a change on the node. We have a timer. And then if all of the nodes report back that the transaction has been successfully applied, we commit it on all of the nodes concurrently. That is why it's so fast. So it's just concurrent across all the nodes. If something fails, we discard or uncommit the transaction on all of the nodes. If there is like a power line break mid-flight when the transaction has been on, but the confirmation cannot come back, then the commit confirm timer will kick in. and the change will be reverted. So even if something bad happens, is there a question? So what the question was about the configurations made outside of EDA on the devices directly. So what happens is that if you configure something on EDA, and that is actually a good demo as well. So let's say we go to leaf 1, and we want to shut down an interface. So we say interface Ethernet 1.1 admin state disable. Before I do that, I want to go back to my system, go to the home tab. You see this block here that is called deviations. Deviations is for EDA to detect what happens outside of EDA that is unsynchronized from the intended changes. Now EDA says that interface 1.1 should be up. This is the intent that is configured by the interfaces application when we build up the playground topology. Now, if I want to switch it to down, right here, I'm disabling interface 1.1, so I will say commit stay. You see right now there's a deviation right away. I did not hit a refresh. It's all streamed from the nodes to EDA. We display it live. What is a deviation? So if I click view here, you will see that EDA detects there is a deviation on, I will make it bigger, leaf 1. The path is interface Ethernet 1.1. The intended value is enabled. That is what EDA wants it to be. But the actual value is disabled. That is what we did on the node. So this is the deviation for the system. Now it stays on the Linux box because currently the deviations are detected and they displayed back at you, so you know what has been deviated from the intent. You can either accept it as a network administrator. You can say accept, reject, and select what you want to do. Do you want this to persist? Maybe this was an intended change, a fix that somebody made on the box for whatever reason it was. But you can also reject it. And if you reject it, you can also make it as a transaction. For example, it's a good example. I will remove this user from the transaction and do a dry run. I can even see what the deviation will yield if I run it. So now it will see that you just changed disable to enable. That was the deviation that somebody made on the box, right? So now I can commit this, and the deviation will be gone. So it will be removed from the node. But I could also kept it in the system if I needed to. Does that answer the question? Yeah, the deviation is quite powerful because we detect them live. You always see them as they happen. You can discard or accept them as well. The question was how we stream the deviation to EDA. So when we onboard the nodes, we set up a GNMI connection to the nodes for the configuration tree. So we monitor all the config changes to the nodes. That means that EDA knows when something is changed on the nodes that EDA itself did not enact. So EDA knows what it needs to do, and it knows that when it receives changes from the node, if it does not match the intent on EDA, that is a deviation. But because it's GNMI streaming, we get it live immediately. We don't have to poll, we don't have to refresh. It's streaming telemetry that we use that enables the deviation handling. This is what we just looked at, right? This is the problem. What if one of the nodes discarded the transaction? We need to revert it all back. And this is how actually we think everybody should do that. You have to validate your changes before you push them. What we did not talk about is the CI/CD story, but just from the configuration part, this is what you need to do. You need to dry run your transaction. You need to see what's in the system, which nodes you target, and then you can see, is the expected diff what you wanted to do? Maybe it's not. And then you go back, you just discard the transaction basket, you go back to enter, fix your intent, run the dry run, and see how it looks like. Then you can either commit it or discard. This is what we did now live with the demo.